and society. In this lecture, we're gonna start in chapter 7, that is the evaluating and controlling technology. We're gonna start in this chapter by discussing the topic of evaluating the information. First of all, why we need the responsible judgment for the information or for evaluating the information. Through the huge amount of information available on the web, much of them is not correct. Another issue, ratings or ranking on the web is done by public, not by specialists or experts. Therefore, we need responsible judgment. An example is the website Wikipedia, in which volunteers write and edit. Thus, we cannot trust what is written in Wikipedia. It is true that those volunteers could be educated, but they are not necessarily expert. In this regard, you may find that the web magnifies the problems of unreliable information. In addition, some viewers in the web could be uneducated or, let's say, less educated people, or also could be children. Another issue regarding the need for responsible judgment is the narrowing the information stream. Some critics see the web as significantly encouraging narrowness and political extremes by making it easy for people to avoid seeing alternatives opinions. Another reason for the need for responsible judgment is abdicating responsibility. So, in this regards, there are some problems. First, the people willing to let computers do their thinking. Second, reliance on computer systems over human judgment may become institutionalized. Last, fear of having to defend your own judgment if something goes wrong. As a way of evaluating information, computer models can be used. But the question here, is that 100% trustful? Is that accurate? Let's take an example. An example of computer model is car crash analysis programs. These programs use a technique called the finite element method. They superimpose a grid on the frame of car, dividing the car into a finite number of small pieces or elements. The grid is entered into the program along with data describing the specifications of the material making up each element, such as density, strength, etc. A real crash test can cost a lot of money. It includes building and testing a unique prototype for each new car design. The crash analysis programs allow engineers to consider alternatives and discover the effect without building another prototype for each alternative. But how good are the programs? How well is the physics of car crashes understood? How accurate and complete are the data? What simplifications do the programs make? How do the computed results compare to actual crash tests on real cars? All of these previous questions are big issues in computer models. The accuracy of computer models depend on the use of this model. Some problems or some use for these models are complex and some are easy. For example, climate change is an example of something that is very difficult to model because for its complexity. Then the question here, why models may not be accurate? First, we might not have complete knowledge of the system we are modeling. So the knowledge of the problems of the model is very important. Second, the data describing current conditions or characteristics may be incomplete or inaccurate. Third, computing power may be inadequate for the complexity of the model. Last, it is difficult, if not impossible, to numerically quantify variables that represent human values and choices. So, by this slide, we complete our lecture and see you in the next lecture.